Hello everyone, welcome to my channel. This is an educational channel. We look at theories of everything in detail and try to flesh them out and show how you can use them in your own life. Most of these things are very obscure. You probably wouldn't know too much about them if not for this channel. And today is the 301st video that we have done on the reciprocal system of theory from Dewey B. Larson. Mr. Larson was an engineer that worked in the 20th century, and on the side, he was dabbling with trying to find some relevant scientific equations to his work. And he ended up stumbling across something that was a lot more all-encompassing and developed that over a period of many years. And in the late 1950s, he put out his two fundamental postulates. And then from there, he took those postulates and through a process of deduction, he built up an entire theoretical universe. About, okay, if these postulates are correct, then the universe works this way. And then he ended up writing a lot of books on things like chemistry and physics and astronomy especially, but also economics and metaphysics, including philosophy and religion and psychology and biology, and developed a small following, dedicated following, and some of those folks have continued the work after Mr. Larson died back in 1990. We're looking at an article that was written by one of those followers, Dr. KVK Nehru from India, and Dr. Nehru started studying up on the reciprocal system, I think, way back in the 70s. And he wrote this article that is called The Space-Time Universe that we're looking at today. I believe today is the 8th video that we've done on this article. And so if you want to go back to the start of the article, go back about a week and, go to part A of the space-time universe. Okay, now the basic idea behind the reciprocal system is that Larson posited a universe made entirely out of motion. Not matter, not energy, but motion. And for Larson, motion was the relationship between space and time. So that sets up a generalized reciprocal relationship between space and time in motion. And motion is basically a fraction with time or space as the numerator, space or time as the denominator. With the caveats that he kind of lines up in the first postulate, that space and time have their coordinate aspects, meaning that they both come in 3 dimensions, like XYZ coordinates or IJK coordinates. And space and time both have their progressing aspects, which Larson referred to as a scalar motion, a motion that has a magnitude and it has no direction. He called that clock time and clock space. So the clock is moving, but the clock is always getting later and later and later, but it's not moving in any specific direction. And that's what Larson called clock time. But there's also clock space. Clock space is that everything is always getting farther and farther and farther apart, which was observed by the Hubble telescope at least in terms of the distant galaxies. All of the distant galaxies are moving away from each other, which you can envision using a balloon with dots on it. If you blow up the balloon, all of the dots are moving away from each other. If you put raisin bread in the oven and turn it on, as the bread rises, all of the raisins are moving away from each other. These are scalar motions or progressions, clock space. And then space and time also only come in discrete units. They come in chunks of a certain size, a very small size, in both the cases of space and time, but they only come in those quantized units. And so if you don't have a full unit of space, you don't have space. And if you don't have a full unit of time, then you don't have time. If you only have, if you don't have 2 full units of space, then you only have 1. You know, that flies in the face of some previous theories, but also if you have 1 unit of space in 1 unit of time, you have the speed of light. So in Larson's universe, the speed of light, or what he called unit speed, is the neutral point of the universe, or the origin, the ether, the reference point, the state of rest of the universe, which makes sense. You know, if you have a universe of motion, the universe is made out of motion, then motion is the first thing that you have. Motion is the thing that you have when you don't have anything else. And you know, so that is a conceptual leap that you have to be able to make. You have to be able to conceive of motion without anything moving. Motion comes before the thing that's moving. And in fact, the thing that is moving is made out of motion also. So you have to be able to kind of make that conceptual leap, and you have to basically assume that in order to kind of delve into the reciprocal system. And what that also does is it creates 2 separate sectors of the universe. You have the material sector of the universe, where all motion is less than the speed of light. And you have the cosmic sector of the universe, where all the motion is greater than the speed of light. Legacy science really only knows about the material sector, evidenced by what Einstein said, that the speed of light is the maximum speed of the universe. Again, with Larson's system, the speed of light is the midpoint of the universe, and half the universe is moving faster. And that is the cosmic sector. But you can extrapolate from one sector to the other because of the reciprocal relationship between space and time. So whatever is happening in the material sector, the exact same thing is going on in the cosmic sector, except that you have to interchange the roles of space and time. So in the material sector, you have coordinate space and you have clock time. Those are things we're familiar with, 3 dimensions of space, and the time is always getting later and later and later. But in the cosmic sector, you have coordinate time and clock space, which are somewhat foreign concepts, but they show that, you know, the rules are the same. It's just that you have to invert the roles of space and time. And you know, this also shows that when you cross a boundary in the reciprocal system, the rules change. And so there's that boundary of the space-time boundary, the speed of light boundary, which Larson calls the unit speed boundary, where you change the rules. And there's also two other boundaries within each sector. And this also comes from the discrete unit postulate, or the quantized nature of space and time. If you don't have in the material sector, if you don't have a full unit of space, you don't have space, which means that you only have time, because the universe is made out of motion, and motion is the relationship between space and time. So it has to be one or the other, or both. And so if you don't have space, you only have time. And Larson calls this the time region. This is the region of action of less than 1 unit of space. So this is really like your microcosmic world, your world of atoms and molecules. Those are going on within the time region. And so the rules are different. Same thing in the cosmic sector. If you don't have a full unit of time, then you only have space. Larson refers to this as the space region. And when you cross that unit of time boundary, then the rules change and you are in a world of only space. And that is where your cosmic atoms and your cosmic molecules, which legacy science refers to as antimatter, that's their realm. Okay, now let's take a look at Nehru's article here. Now, this is pretty much an introductory article on the reciprocal system, and he identifies a number of different, what he calls outstanding achievements of the reciprocal system. Like, so areas within science that he's been able to shed light on that otherwise was a mystery. And he's pointed out of 6 or so of these outstanding achievements. And we're now moving into a section here that's called Galactic Death and the Quasars. And so I think he's moving into the realm of astronomy here, and he's going to point out some of the things that Larson's system of astronomy is able to shed light on that maybe the legacy astronomers weren't aware of. Galactic death and the quasars. We have noted that atoms keep on evolving and eventually reach the upper limit after a long period and then disintegrate. Therefore, the central regions of very large galaxies, which are ipso facto very old, suddenly explode on reaching this upper limit of matter, thereby releasing stupendous quantities of energy. The reciprocal system shows that the magnitude of these explosions is so gigantic that a fragment of the galaxy is ejected at speeds greater than that of light. So it's crossing that speed of light boundary, and the rules are going to invert. This greater than unit speed in the reciprocal system being the speed of light, does not manifest to us as a change of position in space, that is, as a motion in space. Instead, it involves motion in time, that is, change of position in coordinate time. We see such an object with speed greater than that of light as being stationary in our space. However, it manifests other peculiarities, for example, a redshift greater than 1, And if you don't remember, a redshift is, the measure of the Doppler effect, basically on a moving object. If it's redshifted, the more that it is redshifted, the faster it is moving away from us. And so if it's redshifted greater than 1, it's meaning that it's moving away from us greater than the speed of light. One concept that needs elaboration here is that of empty time. While an explosion in space creates empty space between the atoms and results in a decrease of density, an explosion in time creates empty time and gives rise to very high densities, since an increase in time is tantamount to a decrease in space in view of the reciprocal relationship between them. Such ultra-high densities are actually observed in the white dwarf stars, the pulsars, and the quasars. These are all super dense and very small compared to their other, other galaxies, other stars. It is therefore not necessary to take recourse to such ad hoc hypotheses like those of so-called degenerate matter, black holes, and the like. Larson's identification of the ultra-high-speed components of the titanic explosion of the core of a galaxy with the quasars solves all the mysteries that surround these enigmatical astronomical objects. Without stretching the physical theory beyond the limits of rationality, their large redshifts, stupendous energy outpouring, distribution in space, extreme compactness, nature of the emission and absorption spectra, all of them quantitatively agree with the predictions of the reciprocal system. Remembering that the boundary between the cosmic sector, the region of three-dimensional time, and our sector, the region of motion in three-dimensional space, is unit speed in all the dimensions. We see that the superluminary speeds imparted to the quasar material eventually transfer it to the cosmic sector after the gravitation in space is finally overcome. When this happens, the quasar disappears from our view. Exactly the same state of affairs holds good in the cosmic sector of the universe. The cosmic matter congeals into cosmic stars. The cosmic stars group themselves into cosmic galaxies, and the cosmic galaxies eventually disintegrate explosively, and part of the most evolved cosmic matter gets ejected into our material sector from the cosmic sector. Because they come from a region not localized in space, these cosmic atoms appear to be traveling in all directions isotropically and uniformly. Once again, we have the observational confirmation of this in the cosmic rays, whose origin and characteristics are a great puzzle to the conventional theory. All the observed characteristics of the cosmic rays come out logically and naturally in the reciprocal system. Prediction of the other half of the universe and phenomena, therefore, can be classed as the outstanding achievement number 8 of the reciprocal system. It is, now I'd have to also point out, if you want any more details about this, you probably want to delve into Larson's book on astronomy called Universe of Motion. He also has a book that came out that is called Quasars and Pulsars, and has a few chapters in his book that I went over earlier a couple months ago, that's called Nothing But Motion, and he talks about cosmic rays, cosmic ray decay in that book as well. Now, what I'd like to mention also is that Dewey Larson predicted the existence of quasars and many of the qualities of quasars that Nehru's talking about here. He predicted their existence in the late 1950s. Quasars were not actually discovered until a few years later. So Larson predicted the existence of quasars before they were even discovered. So that does show the predictive power of the reciprocal system. You don't have to rely on observations and measurements, and because you have the theory, you have a system that you're working with, and so you can make predictions even if the scientists aren't up to speed yet. Okay. Prediction. Okay. It is unfortunate that the hypothetical nature of concepts like that of quarks, gravitational waves, or curvature of space-time is not well recognized. Especially the proliferation of the so-called elementary particles, with the advent of powerful atom-smashing machines, is pressing the theoretical physicists to the verge of rational thinking and conceiving of quarks in the shape of fundamental building blocks of nature seems to be a step away from reality than one toward it, simply because of the ever-widening number of problems it creates more than it solves. Under these chaotic circumstances, Larson's explanation of these various exotic particles as the evanescent manifestations of different cosmic atoms ushers order and utmost relief to the field of physics. This section is called The Grand Cycle of the Universe. Among other things, with the help of this concept of the conjugate sector of the universe, or the cosmic sector, Larson explains how the universe always remains the same, though always changing and evolving, a truth, once again, of the occult sciences. Diffuse intergalactic nebulae and matter coalesce under the influence of gravity, form stars. Stars aggregate into star clusters, and clusters into small galaxies. These galaxies recede from each other due to the outward progression of space-time. The galaxies cannibalize smaller galaxies and become larger ones, which eventually undergo disintegration on reaching the upper stability limit of matter, ejecting part of the matter into the cosmic sector. In the cosmic sector, a similar sequence of events happen, with the roles of space and time interchanged, of course. And eventually, the cosmic matter ejected from the cosmic galaxies recedes outward in time and enters our material sector at random locations and starts the material half of the evolutionary cycle as diffuse intergalactic nebulae and dust. Thus, on the whole, the universe remains the same, though each half, both the material and the cosmic, continually evolves. The material sector, expanding in space, evolves in time. The cosmic sector, on the other hand, expanding in time, evolves in space. Further, the End of evolution in one sector marks the beginning of evolution in the other sector, cyclically, reminding us of the evolutionary spiral. It is a steady state universe, but without the necessity to break the conservation laws, unlike the Hoyle-Narlikar's steady state model. From another point of view, it is an oscillating universe, but the oscillation is not the banal expansion, contraction in space envisaged by the cosmologists of the exoteric students of occultism, It is an oscillation between space and time, an oscillation that is non-reversing. The expansion toward infinite space in one sector completely counterbalances the expansion toward infinite time in the other sector, in view of the reciprocal relation between them. And on the grand scale of the dual sector universe, we have the entire physical manifestation on the one hand and nothing on the other on equal footing. Okay, that's the end of part 4 of that article, and I believe we'll leave it off there and start with part 5 starting tomorrow. Looks like he's going to get into some quantum phenomena here starting tomorrow. So we'll learn more about that if and when you come back. So thanks for tuning in today, and have a good day.